Welcome to Ballbusters Live. I'm your host Nathan Oakley, and if you are new to this channel or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you'd like to join the community debate, then go to nathanoakley.com and check out the Flat Earth Debate Forum. Now, joining me this evening, we have, in no particular order, Paula, Betty, not Adam Meakin yet, Quantum Eraser, and Anthony, otherwise known as Sleeping Warrior. Very good to have you all.
Thank you.
Thank you. Good evening.
Ahoy hoy.
Get out.
Get out? That's not a very nice intro.
Ahoy hoy. There's only one Burke that uses that intro.
Planner Walk, right?
Let's not mention his name. It's a cuss word.
He got toe tagged.
He did get toe tagged.
He doesn't know what an independent variable is, the moron.
So if I said to you that gravity is not a force, but you can think of it as a force, would you know what I was talking about?
Yeah. I think everybody knows what you're talking about with that sentence, right?
Well, I could put it in quote marks and say George Musa 2019, and then people would definitely know who said it and when it was said.
I don't think you need to. You must have been living under a rock for the last month if you don't know what we're referring to with that sentence.
It's a gift. It was a true gift, that interview. Wonderful, wonderful. But it's kept the subject alive that much longer. You know, obviously, you know, we want to see it in its death throes, and that's where we're at, watching a dying corpse of gravity. But, you know, as our foot's on its throat, we might as well continue to rip it to pieces, because there's still some nonsense that's left out in the ether. Bending of space-time, conceptual mediums, all the current nonsense. Yes, we don't have a force, but there's certainly a current rhetoric, would we not all agree?
Yeah.
Yes.
Enthusiastic Ballbusters team.
They're hyper boy. And listen, that's not the that you mispronounced independent variable. Betty.
Yeah.
Please.
Independent variable. Variable. It's
There you go. Thank you.
Independent variable.
variable.
Variable. Variable. Okay.
Yeah.
Variable.
Independent variable.
Ahoy hoy.
So about that independent variable, that would be needed, wouldn't it, if you were talking science? And gravity, does it have those?
No. And we're going to get into that. Most Ricky Tick.
So there's no scientific evidence of gravity, and on pretty much every single flat earth debate we ask that exact question. Is there any scientific evidence of gravity? And alas, none is ever offered. Plenty of pseudoscience for the formerly known as a force, gravity, which was superseded by Einsteinian gravity, pseudo-Ramonian for space. Space-time! That bullshit medium that you never get to experience and absolutely in no way can manipulate.
And which quantum mechanics is pummeled into the incoherent oblivion. But no, they just keep whistling past the graveyard. Space-time! They don't even do that space-time. They're on to the force. I mean, this is like Star Wars. Force. You could tell them 25 times, the next statement out of their mouth will be, well, what about the force?
Yeah, it's bad. It's really bad.
Yeah, but it's comical. There's a
Right,
lot of Luke
let's crack on.
Skywalkers out there on the ball side, right?
Say again?
There's a lot of Luke Skywalkers out on the ball side of this debate.
Oh, yeah. Those definitely, man.
You know, I was asked by somebody who shall remain nameless for his own protection, I guess. He asked, why is it that, like me, Quantum Eraser, Nathan, won't go on Jose's channel? And I says, well, I don't mind going on Jose's channel. It's not that we won't. It's that we choose not to. And it's not for any commercial or competitive reason. It's just because And I'll be honest and I'll be blunt. It's because of the drongos that are on his panel. You can't have a conversation with them because they overspeak you continuously. And you can't talk to people that are overspeakers. They will. It's like Rumpus, like Sean Hawkins and Rumpus. They're of the same breed. You can't converse with somebody that continuously interrupts you, and that's the reason.
Yeah, it hasn't changed from the beginning. It's
Correct.
been that way from the start. It hasn't changed. It's the same thing. So,
Is there actually any?
you know,
Is there actually
Go ahead.
anybody there that we haven't been up against already on Flat Earth debate? I mean, is there any newbies there?
No, not that I know of. No.
So they've already been here. We already have had. You know, you could repeat one of those shows. Just go back to one of the old Flat Earth debates, and you'll see the same characters getting ripped to pieces.
Anyway, let's crack on.
Indeed, we've got a presentation to do. Let's not discuss debating shows when we've got Gravity to rip a new one. Let me know if you're ready to present, John.
ready.
Excellent. You're up.
Yeah, we talked about Gravity. I think it was 4 or 5 weeks ago. I don't remember the episode, but like we've been talking about, Gravity has been up to the front and in center of focus, especially since the George Mooser interview, and everyone's been talking about it, man. So I decided to go ahead and do a Gravity presentation again. This isn't the same Gravity presentation. We'll go over some of the same topics, couple little twists. We won't spend too much time on Einsteinian gravity. We'll hit them a couple times, but not to the depth or length that we did the last time. If you want to see the quantum mechanics deconstruction of Einstein, just go back to the last Gravity presentation and it's all there. So I'd like to start out with what science is, and you'll see why here in the next few minutes. So, from the University of Rochester Physics Labs, the scientific method distinguishes science from other forms of explanation because of its requirement of systematic experimentation. That's a very important word right there. The requirement of the scientific method is systematic experimentation. That's what distinguishes science from everything else. From cakes, from chicken noodle soup, from badminton, you gotta have this to have science. It's just that simple. Right? So how do we get to experimentation? Well, to get to an experiment, you have to have a hypothesis, because an experiment is a hypothesis test. So let's see what these are. Scientific hypotheses. From California Institute of Technology physicist Sean Carroll, arguing in The Edge that hypotheses aren't simply useful tools in some potentially outmoded vision of science. They're the whole point. So what are they? From Lowell C., Strategic Thinking for Scientific Discovery, Becoming a Successful Scientist, Cambridge University. A scientific hypothesis is based on what? Cause and effect reasoning. A scientific hypothesis does not merely state X and Y may be related, but explains why they are related. From Drexel University, the scientific method is hypothesis-driven. Duh. One makes an educated guess to explain a cause and effect relationship. From Anne-Marie Helmenstein, PhD Biomedical Sciences.co. A hypothesis is an educated guess based on an observation. Boy, it sounds like an echo. It's a prediction of what? Cause and effect. So, from the Institute of Physics, when planning an investigation, students need to identify the variables that they consider significant and then select the ones they want to look at for cause and effect. Shocking surprise. If possible, any other variables that will affect the outcome of the experiment need to be kept constant during the investigation. Constant, controlled. What are these? The independent variable, i.e. the cause, dependent variable, the effect, and control variables. Even Wiki, their alma mater, the Baltards' alma mater. An experiment is a procedure carried out to support, refute, or validate a hypothesis. experiments provide insight into what? Cause and effect, by demonstrating what outcome occurs when a particular factor is manipulated. Take a wild friggin' guess what that particular factor being manipulated is. Maybe it's the independent variable. Who knows? We'll keep it a secret. Let's tie a bow around gravity, both Newtonian, that's Reverend John Michel Cavendish, and Einsteinian's disheveled monkey, and pulverize them based on what we've just gone over up above here. And it's going to be real easy. From Martin Rees, astronomer royale with cheese, esteemed British cosmologist, astrophysicist, the University of Princeton Press. What causes gravity and mass? These questions still baffle all of us. So what in the world, guys? According to Professor Rees, does mass attracting mass cause gravity? Nope. According to Professor Rees, does space-time cause gravity? Nope. Turn out the lights. The party's over. They say that all. You get the idea. Questions, comments?
So are you telling me they haven't got a cause to manipulate when they make up gravity?
Appears not.
Then it's not science.
Precisely.
Well, I have someone that commented to me today, I think, that was the fact that, I quote now from him, the fact that hypothesis can sometimes be based on cause and effect reasoning does not mean that the entirety of science is about cause and effect.
That's quite interesting. Didn't we just go over the basis of science?
Yeah, but he seems to have a problem with that. So I asked him for a couple of examples, and he has provided, but I didn't go over them yet. So we'll see what he brings up.
Well, you can't have science without experiment, and you can't have an experiment without a hypothesis, and you can't have a hypothesis without an observed phenomenon. So, I don't know. We're going to play the fantasy game?
Well, I asked him for the hypothesis and what tests were used. So I hope that he will be able to come back to me with examples and explanations for that.
I can't wait to see him.
Yeah.
Paula, any comments?
I think when people say things like that, they're confusing, they'll always give the example, say for, the computer you're using is the result of science, but it's more the result of engineering, which isn't necessarily science, because you're not trying to prove anything. You're trying to make something work, and you're just being creative, and you're using the basics that have been, the theories and whatnot to, for example, come up with, okay, I need a certain circuit to, the computers are always made of bits on and off. Well, that's made of components that you put a certain amount of voltage on to a certain device, like a diode or whatever, and it's going to have voltage at this point. That's engineering. That's based upon science. So when they say something like, if I was following Betty right, that is kind of an offshoot of that, really, but related, that people will always say that this is, you don't need the scientific method all the time because you can do science without it, but they're confusing engineering with science, just to try to make that observation.
Yeah. And more than that, I think they also think that discovering things in how things, they discovered, for example, in the cells, what's going on there, but that's more discovery than it is science in the sense of cause and effect. They call it science, but it isn't.
Precisely, you're answering a what is question rather than a cause and effect question. You got it.
Yeah, and then you have these people that think that stats or statistics is science too, like that bird humping thing with the birds, so many birds in so many areas and stuff. Yeah, that's.
Wait a second. Wait a second. You got birds humping statistics?
I think they might have.
If only
And
there
it
was
doesn't
a-
help when people use terms like computer science. My son, for example, that was his major in college, computer science. And it's because science has a semantic range like all other words do. And they will call something a science just because it's a field of study. And I think there's a lot of confusion caused by that use of terms.
Oh, can I clear that up? We're talking about natural science.
Yeah, physics.
Yeah.
Yeah.
Well, this is typically a discussion in regards to the world we live in, the physical and natural world. So I'm not that interested in how a computer functions in that regard. Knowledge, though scientific in terms of its etymology, might be accurate. We're talking about the physical and natural world. That's natural science.
Yeah, but what's more natural than birds humping, right?
Well, that might be the case, but establishing a cause of an effect is ultimately what we're talking about when we're establishing cause and effect relationships, which often we are levelled with in the discussion about our world and what causes things to happen. In the case of gravity, although I was going to say it would be useful if we have some, I don't know, catchy term for varying and manipulating an independent variable. If only we had one of those catchy phrases. I just can't think of one.
I know one. What about Wiggle It?
Oh, I don't know.
Yeah.
Anthony sharp as a brick.
No, I was just being respectful. This is where the gravimeter fits into stuff, because Bob likes to push the idea that there is some kind of downwards acceleration force. And I agree with Bob in principle. There may well be something, but the problem is if you describe it in the terms of downward acceleration force or use the word gravity in any way whatsoever, the ballers immediately steal that context and say, well, we agree on everything then. And that's just the intellectual dishonesty of the ballers. So whilst Bob accepts gravimeters are proving that there is some kind of downwards acceleration force, this is where the cause and the effect comes into it, because it's the same with the ring laser gyros. If they are measuring something, the question is, what is it that they're measuring? And you have to wiggle it to prove that it's measuring the thing that you believe that it's measuring. You can't just claim it and then give it a name called gravimeter and then claim that it's measuring a downward acceleration force. You've got to prove it. So if it is measuring something, then prove it by demonstration. Otherwise, it's just a story and it's not science.
Yep.
Sweet. I'd like to get back to the birds humping. There's definitely a cause there. What's the cause of birds humping?
I don't know, good looking nest.
Well, I know the effect is an egg.
No, well, that's the effect. What's the cause of the birds humping? But is birds humping a phenomena?
Well, you can think of it as one.
Never gets old. Right, can we move on from birds humping? Can we get back to the presentation because we're way off track? Shout out to Sam for the super chat. Thank you very much. Nathan, if you can come up with the other 34,950, you can spend it on one night on the ISS. Oh wow, that's like a contribution towards me going up to the ISS. I really appreciate it, but that light in the sky, we ain't ever going to that. The set, if that's going to get me on set, man, I'll take it. Ready when you are, John.
All right, I stopped a little bit early. That's all right. We can just roll right through here. This is an easy one. So, by the way, real scientific theories identify the cause of the effect. I know, shocking. And even Georgie fucking Mooser said 2019, oh no, not at all, to the question, from fat to fat Earth, we still don't fully know the complete cause of gravity. Okie dokie, the general theory of relativity is a theory of gravity, right? So, ballers, you have a scientific theory without a cause? I mean, that's like having water without hydrogen. For goodness sakes, people. You got nothing. Alice in Wonderland has more veracity. This gravity, this 9.81 meters per second squared, which is bullshit by itself, is merely a description of an effect, not a cause. And remember, no causey, no sciencey. Now to the coup de grace. Newtonian gravity. What's Newton's law? Balltards will invariably say or post this, right? We all know this. So many thousands of times have we seen that. That's not Newton's equation, folks. This is. You see any big G in here? This is a proportionality issue. These are two different equations. Just to let you know, this FG equals big G, M1, M2 divided by R squared is Reverend John Michel or Mitchell Cavendish / CV Boy's little addition. And you know what? Now that I'm looking at this, I may be taking these two boneheads out and just leave it at CV Boy's door. And I'll show you that here in a second. This is 207 friggin' years after the Principia was published and 167 years after Newton's death. This isn't Newton's equation, folks. No. So big G, like I said, Newton's universal law of gravitation was published in the Principia July 5th, 1687. And this was the equation. You see big G in here, pretender clowns? Probably an aberration, right? Number two, Cavendish didn't conduct his alleged non-experiment, which should be known as the Reverend John Michel Cavendish experiment, until 1798. That's 111 years after the publication of Newton's Principia and 71 years after Newton's death. Number three, Cavendish.
Oh, we've lost audio from you, John.
Not on mute, he must have dropped.
No, because we've still got a screen share. Just lost the mic.
He can't hear us, can he?
I don't think so. Can you hear us, John? He can't respond because he's lost his mic.
Yeah, but he's not moving around, is he?
Maybe his screen froze, maybe.
Maybe his screen froze
I
because he
reckon
has dropped and it'll temporarily.
Well, rather than have dead air until we work out what's going on, should I just jump in and do my presentation?
That might be an idea.
Because it could be 3 minutes, it could be 10 minutes before he gets back.
That's true.
Let's go with the assumption that he's going to be a few minutes, and rather than have dead air, I'll just rack up my thing. Hang on.
Oh, well, while you're doing that, then while you're getting prepped for that, fortunately, John got to the end of the most critical part of the presentation, which was him presenting the difference between those two equations. So he's got it. Hopefully, he'll reiterate it. I'm in a way kind of pleased, or half pleased, because he can start at that again and reiterate it, hopefully to an even larger audience as the audience grows. But yeah, if you're ready to go, Anthony, mic's all yours.
Yeah, I'm ready to go.
Evening, Tony.
Oh, hello, Adam. That's quite conveniently timed also. Good to have you. The
I
Adam
literally just caught the end there. So what's he just demonstrating the difference between Cavendish's formula and Newtonian's?
On the contrary, so it would seem that the Cavendish experiment, in quotations, is devoid from any of the equations. So it's this boy's guide that's actually given us the equation, and it's considerably after the death of Newton. So the that was going to be the question I asked, actually. Well, where does the actual Cavendish quote-unquote experiment fit into all this? Is it literally just a circus sideshow? Because it's seeming that way. Do you know what I mean? So we'll find out, hopefully, when John returns. But he's been sitting on this for quite some time, which is frustrating if he's just lost his connection at the most critical point. But he did actually make the point, which is good. So, yes. Right, I can see you're scrolling away, Anthony. Did you want me to present you?
Yeah, I'm ready. Let me know when we're presenting.
Okay, yeah, you're presenting now.
Okay, so this is, whilst John's away, this is to raise awareness to what Ballbusters have just released. I love this guy. His name is Julius Sumner Miller. He died in the 80s. He's gone now, so don't worry, the trolls can't get to him. But what Bob's done here is beautiful, because he's put, for those physics-challenged individuals who believe that no natural downward acceleration exists and relative density alone explains up and down. he's obviously referring to the people that are pro-relative density, and there's quite a lot of us, and we get it. This video, this is going to appeal to everybody that is understanding how relative density works. And if it doesn't resonate with you, then you don't get it. If this resonates with you, then you do get it, and this is going to be brilliant. What I'm going to do, I'm going to get it to cue it up, and then I'm going to read my message to Bob first, because Ballbusters has got he has to authorize every message. It could be a while before mine gets authorized, or it may never get authorized. So in the absence of it not being authorized for some reason, I'm going to read to you what I've put. And then I've put, and for those that cannot disagree properly and suck with evidence, claiming gravimeters are proof of something need to demonstrate what it's actually measuring with experiment. Claiming it is only half of the battle. Demonstrating it is the fundamental second part. No demo, no proof. Simples. Science, bro. Independent variable, cause, effect, phenomenon. P.S. From 1755 and until he finishes the sentence, and I don't care what the scale reads, it reads something. Why does he add that line when it's totally unnecessary? That one poignant addition should tell you something, and I bet you'll simply dismiss it. But why does he add that line if it's totally unnecessary? And I'm going to play the clip in a minute so you can see it. But basically, if there's not a contentious issue, there doesn't need to be any further explanation. He would literally just say when he puts a weight on, this weighs X. But he doesn't say that. He makes 3 additional comments that are totally unnecessary. I continue. He adds the line because he knows it isn't measuring weight or mass. If he thought it was measuring weight or mass, he wouldn't add, quote, we say it weighs the weight of the body, but I really don't know what that means. For a PhD level professor, for him to say that, which is his second sentence, in addition to what he's already said, seems to be really perverse, almost. Funny, relative density supporters totally get why he says that. So, Bob, can you explain why he's so weaselly with that section? I'd love to hear what your explanation is for that. And then finally, when he adds, without any need whatsoever, nor did Newton. The guy clearly knows that gravity is not a force. Absolutely no need at all for this commentary to be in. All he had to say from the start was it weighed X, like, I don't know, a kilogram or whatever. Come on, Bob, you know you need to join our side. They all float down here, obviously citing from the clown thing called IT by Stephen King when he's in the drain. Anyway, so what was the timestamp? 1755. So it's only 3 sentences, and I want you to listen to what he says here, because all he has to say when he's putting this weight on is that it weighs X. But listen to how he doesn't say that. He goes further. When I pass the sound through now, it'll be one of these two. It might even be that one.
Can you make it full screen?
Maybe. I'll go with that one first because I need to make sure that the sound comes through.
Here is a scale.
Oh, hang on. It's double speed.
Yeah, the sound came through.
Did the sound come through then?
Yeah, but also so does mine.
Just give me a sound check.
On
Everything's
which I
fine,
hang
just
a
play
weight.
it.
What? Nathan, did the sound come through or not?
Yes.
The second law. Here is a scale on which I hang a weight. And I don't care what the scale reads. It reads something. We say it reads the weight of the body. But I really don't know what that means. Nor did Newton, because as we believe, gravitational forces, the Earth pulls on this, stretches the scale. But remember, even Newton said, I offer no hypothesis concerning gravitation.
So I only went into that. Did you hear that okay, by the way?
Yes, but you now need to change the sound back because you're getting horrendous feedback.
Is that working?
Check. Yeah, that's fine now. No, we still
So-
get horrendous feedback from you.
Is that it?
No. Yep, all good.
So what he's just demonstrated there is numerous sentences. I only picked on the first 3, but there was 4 or 5 there, none of which were necessary to make the point that he was saying that there is 10 pounds or 10 whatever units these are. But if you think back to when I did my density experiment with the egg in the water and I used my ppm meter, I made a conscious point to say that, and I don't know what that number means. It doesn't mean anything. And the reason why I said that is to emphasize the relativity of the point. And the ballers just said, how can you claim that this is density if you don't even know what it's relating to? And that just shows that they don't understand what's going on. But my point is this. This guy at 17 minutes and 55 seconds spends a good 30 seconds or so, just under 30 seconds. Basically, rather than saying that this weighs 10 pounds or whatever, he goes into great detail for why whatever this is weighing, he doesn't understand it. A professor. But if you understand relative density, you'll understand and resonate absolutely with what he's saying here, because it's measuring the disparity between the weight of the candle wick or whatever this thing is at the bottom relative to the medium it's in. You'll get it. You'll understand it. And it'll just sit there, and you'll just sit there with a smile on your face. But if you're a relative density denier, you'll have no idea why he's saying this, and you'll think that we're overanalyzing it. So you've got the paradigm to come to the conclusion of, well, what is he referencing when he says this stuff? Is he referencing some attack on Newton? Is he referencing relative density? Why is he making a big deal over something that all he had to say was, when we put the weight on, it weighs 10? That's all he had to say. So go and watch this video from Ballbusters. Look at 1755 and play it back 2 or 3 times for the next 30 seconds. It's absolutely brilliant. The guy knows that there's no such thing as gravity. He knows that Newton was wrong. And he knows that these things that we're measuring the mass of, we're not really measuring the mass. We're measuring how far out of disequilibrium the object is. And it's the net effect of the disequilibrium. That's what we're really measuring. Now, that's going to take a while for it to sink in for people if you're not with this conversation. But I watched I can't remember, what was his name now? Somebody that's come on the show, forgive me, I can't remember his name. He was on Non-Sex Show, and he was talking about relative density, and he was absolutely brilliant. But because there was 2v1, he was able to be outmuscled wrongly, in my opinion. But people are getting this now. People on our side realize that relative density does kind of explain an awful lot. If it's in a state of disequilibrium relative to the medium, then it's going to have what we call weight. But it's just how far away it is from its own relative equilibrium position. Like Arwin talks about relative density disequilibrium. Me and Arwin are on the same page now. So anyway, that's me done. So just check out that Ballbusters video.
Paula, anything to add to that?
Not really. I think the point is made that this professor, and I used to watch him back in the day, that this was, he always had such a good way of explaining things, and he didn't care as much about theoretical physics as he did with practical, everyday, mechanical physics. And what he's saying, the point that Anthony made is that they don't know what is actually causing the vertical force. I think vertical force is a better name, because sometimes it goes down, sometimes it goes up. It depends on the density, the interaction. I've been posting a thing in the chat that it was a quote from physicsclassroom.com, that a force is a push or pull on an object resulting from object's interaction with another object, and forces only exist as a result of an interaction. So there's the way materials or substances behave when they're within a certain distance of each other is what makes the force. It's the inherent energy in each of the objects that makes the force. So that's about as close as I think we're ever going to get to it, cause of quote unquote gravity. But this interaction isn't always down, and it isn't always vertical. You can have things go sideways, like when a gas disperses. So, but certain types of things tend to go down, and certain other things tend to go up. And this is that interaction because of disequilibrium. So it all ties together, I think.
The other thing to mention as well is when they talk about, even when Musa talked with Craig, George Musa was asked by Craig, we still don't really know the cause of gravity. And he says, no, not at all. It's almost as if they're telling you that it's the way it is because that's design. In other words, it's that way because it's been made that way, and it's really the proof that something's created it this way. Now, I'm not saying that I'm not meaning to push this into a religious context, but they can't say that they don't know what's causing this stuff if they're going to call it gravity, because it's either mass attracting mass, bendy space-time, or it's not. If they don't know what's causing gravity, it's not bendy space-time and it's not mass attracting mass. They might as well just admit that it must be the way it's been designed, and that must mean there's a creator.
Yeah, it's just a law. That's what I see.
Yeah, it's a law of nature because that's the way it's been designed.
Yeah, it searches out where it belongs, right? As opposed to the density or gas or liquids or things. Just sorts itself out, and that's how I don't see it as a force at all. Personally,
I don't think anybody sees it as a force anymore because we've hammered that. You can think it's not a force, but you can think of it as a force. That point's
Yeah.
been hammered by so many people now. It's become an ongoing joke now, and I've heard other people referencing it as well in chat, and it's brilliant.
yeah.
I want to welcome back Quantum Eraser. How you doing?
Hey, how's it going, man? How long did I go on before I realized I was cut?
Well, you got the main point in, but I'm in a way I'm slightly glad because it means I can give it a bit of a drum roll before you start the whole point over, because it was something you've been sat on for a while. But I'll just get our remarks from Adam, and then we'll move back on to your presentation if that's good by you.
That's fine.
Adam, you there?
Yeah.
Any comments?
Just a quick. Yeah, I'd echo what had been said regarding Tony's bit. All I would say is, as he was kind of alluding to, I think, from my perspective, when he talked about it weighs whatever.
Anthony, excuse me a second. Anthony, yeah, you are echoing, Adam. Anthony, can you please go on mute?
Is that better if I talk? Yeah.
Good.
Yeah. So my only point really is that he was talking about the reading. And all I would say is that reading is generated initially by setting the apparatus up, hanging a thing of 1 kilogram, whatever, off of it, and then on the scale drawing a 1. The scale is generated from reality. It isn't generated by the mathematics of the supposed Newtonian forces acting on it. We use it in reality because it's derived of reality. That scale, whatever you want to consider the concept, is derived through experience, not mathematics.
Well said. Okay, so I'm now going to give a proper drum roll. So as I say, Quantum Eraser has been sat on this for several months, and he's been waiting for someone to rear their ugly head in the debates and mention the equation. They just haven't. That's the bottom line. There's been a couple of hints at it, and I've even tried to feed a couple of people to John in the debates, and he's gone, no, they are not worthy. But it's made its way onto Ballbusters, because I think since it was discussed and, due for a pummeling on the debates, I don't think Ballbusters was even around when you first had this, right, John?
No. Hey, before you get to that, Adam, can you please go on mute?
Oh, sorry, son. Sorry.
Because you're causing the feedback.
I caught it again. Sorry, pal.
Thanks.
I'll mic up put my headphones on as well.
Sorry about ruining that, Nathan. Go on.
It's all right. Sometimes, you're going to have a bit of production talk in the middle of these live shows. Just ignore it in the audience. That didn't just happen. we didn't just have a session of feedback.
But they can think of it as happening.
They can think of it as happening. But no, that did actually just happen. Anyway,
Before
right, let's
it
get back
happens
onto...
again, then, is that better now, John? Is that everything controlled?
I still hear...
They're the snakes. I can't help them.
If you can, just mute in Skype. That'll definitely solve the problem. Right, I've got your backup presented, John. And I'll do the drum roll again. So this is an important point. I'll shut up.
Hey, now, did we get past the no causey, no sciencey part?
That's about where we lost you, but I want you to start from the equation again. So start with Mr. Boyle and Cavendish Mitchell.
Okay, yeah. Newtonian gravity, like I said, if you ask what's Newton's law, then invariably from any of the ball-tards, you're going to get this equation, right? You're just going to get it. We've seen it thousands of times. Everyone knows what's coming. But that's not Newton. This isn't Newton's equation. This is. So it looks very different. There's no big G and no equal sign. This is a proportion. Big difference than that equal sign right there. And like I said, no G, no big G. This big G came from, and like I said, I don't know if you caught it, Reverend John Michel and Cavendish, and I'm considering it didn't come from them. So I'm considering dropping that little maneuver from them because they had nothing to do with it. I'm leaving this anchor at CV Boys because that was his little addition. It was 207 years after the Principia was published and 167 years after Newton's death. So, Big G, or what they say is Newton's universal law of gravitation, was published in the Principia, July 5th, 1687. This was the equation, like I said. You see Big G in here anywhere, pretender clowns? No, you don't. Cavendish didn't conduct his alleged non-experiment, which should be known as the Reverend John Mitchell Cavendish experiment, until 1798. That's 111 years after the publication of Newton's Principia and 71 years after Newton's death. Number 3, Cavendish didn't calculate a numerical value for G or M. Let's take a look at this. So we got Lauren Hodges, Department of Physics and Astronomy, Iowa State University. And listen, I never looked up here. I'm telling you, I didn't. So they're copying my Michelle Cavendish experiment. I'm standing by it. Let's take a look at what they got here. So Cavendish's paper, right in this vicinity, folks. Cavendish's paper did not disappoint me in this respect. There were 3 major surprises awaiting me. First, Cavendish did not determine G or M. He determined the average density of the Earth. Wait a second here. He didn't determine M, which is mass. We're going to get into that a little further in the presentation. But he determined the average density of the Earth. How did he manage that little magic trick? Density is mass over volume. You need mass. We'll get back to that here in a second. Number 2, second, while he presents his raw data very completely and carefully, Cavendish made an error in his I don't really care, because he didn't calculate G or M. Number 3, the third, and most surprisingly, the famous Cavendish experiment and Cavendish apparatus were not designed by Cavendish, by geologist, the Reverend John Michell, right down here. You see him? So it's appropriately named. You know what? Let's get back to this. I want to see how you figure density without mass. That'd be a good maneuver. Let's go in there and find it. Finding the density of objects without measuring mass. All right. We'll go to the Institute of Physics. Got the abstract up here. Let's see how we can do this. A simple method based on the moment of forces. Really. And Archimedes' principle is described for finding density without measuring the mass or volume of an object. This is going to be a neat trick. The method involves balancing 2 unknown objects of mass 1 and mass 2 on each side of a pivot on a meter roll and measuring their corresponding moment arms. Really? So I want to see somebody who put the Earth on one side of a pivot on a meter rule, because that's how you need to do it. This is quite preposterous, folks. I mean, the more we get into this, the more nonsense we find. So the bastardization of Newton's law, Big G, didn't make its appearance until 207 years after the Principia was published. So wait for it. It's not Newton's law, for fuck's sake. Moreover, the Ballbusters ascribe gravity to Newton. Let's take a look at this. From Stanford University, in a letter to Dr. Richard Bentley on February 25th, 1692, Isaac Newton says, "'Tis inconceivable that an inanimate brute matter should, without mediation of something else which is not material, operate upon and affect other matter without mutual contact, as it must be if gravitation, in the sense of Epicurus, be essential and inherent in it. And this is one reason why I desired you would not ascribe innate gravity to me. That gravity should be innate inherent and essential to matter, so that one body may act upon another at a distance through a vacuum without the mediation of anything else, by and through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into. Gravity must be caused by an agent acting constantly according to certain laws, but whether this agent be material or immaterial, I have left to the consideration of my readers. So I don't know why you guys are ascribing gravity to Newton. He told you directly not to do it. And this last little bit must be caused by an agent. Guess what he's talking about? God. An agent. And he's kind of saying, he's kind of straddling a fence right here by putting this material or immaterial in there. I can't speak to that. It sounds like fence straddling to me, probably because of the moment of the times. So turn out the lights, you mindless parroting wiki pretender clowns. You're toast. You have absolutely no friggin' clue as to what you're talking about. That's what you get for mindlessly parroting wiki or priest from your ball-tarred, spinning space monkey congregation. Let's stop right there.
Cool. Now, plenty of weight behind it, and plenty of cowbell, as you would put it. Anything to add, Paula?
Did you say plenty of weight behind it? Yeah, when you actually read this stuff and how people use it, people wonder, why are we going over this? And it's because the ball earthers continually say those words. Newton's law of gravity and Einstein's law of gravity, and they'll say, well, Newton we can use for, most practical purposes. But what you just read there is no, I'm not telling you what's causing it. I'm just watching what happens. That's how you can make a scientific law. Is it's just observation and saying this always happens without exception. That's a scientific law. And then they can derive mathematical relationships from that. And that's all Newton did. But looking for what makes it happen, that's been the problem. And that's the whole reason why Einstein had to do what he did. Well, one of the reasons, to try to actually find a cause. And all he did was move the goalposts to the trampoline with a bowling ball in the middle, which explains nothing at all. It's ridiculous. But yeah, I mean, it seems pretty obvious to me what Newton is saying there.
Betty, you got anything to add?
Yeah, it's fascinating how along the times things have been add on and it's like someone started a story and phrases are being added to it to make it work and to make it in a good happy ending. But it is a house of cards, basically.
I phrase that as they smear on yet another layer of bullshit. Right, you Adam, you got anything to add?
Yeah, I mean, I'd probably say the same. And John, if you just scroll back down to Newton's quote there, I think he was, I think we all agree, a very intelligent man. And I think he's, in his writings here, realised that what he's proposing isn't backable. It's not even really describable by him. But I think he's smart enough to realise that people are going to ascribe certain things to it, and in his own writing he asks you not to do so. So I would suggest probably 300 years later he's turning in his grave at what's been written in his name, what has been quoted. And the formula is probably the cutest example of the misquote.
Anthony?
Anthony left.
Has he got stuff to get on with? Well, he got to do his presentation. I'm sure he's very pleased. In that case, I've got nothing to add. John, if you want to carry on, you're more than welcome.
So, Baltards, please provide that formula with big G in it and the equal sign to me. I want you to do it. Because you're all busted, man. You're all busting for parroting the wrong pseudoscience. Let's just make that perfectly clear. All right, yeah, we can move on. So we're going to go back to the Iowa State and just stress this Reverend John Mitchell. The evidence is clear that Mitchell and Cavendish both deserve credit for the Cavendish experiment, which should probably be referred to as the Mitchell-Cavendish experiment. It was Michel who thought the experiment up, including inventing the torsion balance that is at the heart of the experiment. It was Michel who built the original apparatus for the experiment, and the apparatus clearly capable of producing the results desired. The fact that the purpose of the experiment was to determine the specific density or the specific gravity, i.e. density of the Earth, suggests that geology, rather than theoretical physics, was the motivation. So, like I said, I want to hear it now. If you're going to mention the Cavendish non-experiment, I want the Reverend John Michel Cavendish non-experiment. You got to get that right, folks. So, to the gravity hypothesis from the Principia, somebody mentioned this before. No, I think it was Anthony's video that he was just mentioning this. From the Principia, I have not as yet been able to discover the reason for these properties of gravity from phenomena, and I do not feign hypotheses. For whatever is not deduced from the phenomena must be called a hypothesis, and hypotheses, whether metaphysical or physical, or based on occult qualities, or mechanical, have no place in experimental philosophy. In this philosophy, particular propositions are inferred from the phenomena and afterwards rendered general by induction. This thing is so pregnant. I can spend an hour just on this. I'm not going to. We already talked about induction a few days ago. Has nothing whatsoever to do with the scientific method. The scientific method is purely what? Abduction and deduction. I just want to concentrate on this one right here because a lot of this is occult experimental philosophy. I don't know what the hell he's talking about. I do not feign hypotheses, right? He makes no hypothesis because he can't. It's nonsensical. It's not science. Remember, California Institute of Technology physicist Sean Carroll arguing in The Edge, hypotheses aren't simply useful tools in some potentially outmoded vision of science. They are the whole point. So, Sean, Newton said he has no hypotheses or hypothesis for gravity. Ergo, how can it be friggin' scientific then? Hello, McFly. Moreover, the Ballers scientific community, aka pseudo-scientific non-community, doesn't follow Newtonian or Cavendish gravity. Listen, I'm using Newtonian here just so everyone can identify in the distinction. Like I said, I'm pulling Newtonian out of this. So, from George Musser, the favorite quote of the day, Einstein created his general theory of relativity, which provides our modern understanding of gravity, with the express purpose of expunging non-locality from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two by showing that the curvature of space-time and not an invisible force. Not an invisible force gives rise to gravitational attraction. So what's he talking about here? Relativity snapped the wand in two, the magic wand. Well, what wand is that? Well, it's the magic of Einstein's or Isaac Newton's gravity. This is real simple to reconcile, folks. I don't know what the big deal was with this. I mean, George Mooser couldn't get out of this. There's no way he could. Gravity is not a force. Let's just pound this in for you, okay? From Caltech, Einstein came up with the theory of general relativity in 1915, the prototype of all modern gravitational theories. Its crucial ingredient, involving a colossal intellectual jump, is the concept of gravitation not as a force, but as a manifestation of the curvature of space-time. Brian Cox, there isn't really a force of gravity at all. George Mooser, 2019, see Fat to Fat Earth, gravity is not a force, but you can think of it as a force. Even the Alma Mater Wiki, gravity is most accurately described by the general theory of relativity proposed by Albert Einstein in 1915, which describes gravity not as a force. And by the way, real scientific theories don't describe, they explain. From the universe today, in general relativity, gravity is not a force between masses. From the University of California, strictly speaking, gravity is not a force. From physics.org, according to this theory, gravity is not a force. From New Scientist, so although the Earth appears to be pulled towards the sun by gravity, there is no such force. From Physics Libre Text, the answer is that gravitation is what? Not a force between two objects. From the Physics Hypertext book, gravity isn't a force. Do you get this? So now we got, after all this, Wonder Twin powers activate. We got Physics for Kids and NASA. I think NASA got it from Physics for Kids, be that as it may. So from NASA, gravity, an invisible force that pulls objects toward each other. Anything that has mass also has gravity. Objects with more mass have more gravity. Earth's gravity comes from all its mass. And Physics for Kids, Ducksters.com. Gravity is the mysterious force. It's not just a force now. It's a mysterious force. Booga, booga, booga. That makes everything fall down towards the Earth. It falls down, goes boom, boom. Only in Shangri-La, folks, can we base reality on paradoxical contradictions. Comments, questions?
Paula?
That earlier statement about snapping the wand and getting away from an invisible force at a distance. Well, is space-time visible? You know, if that's the antidote to an invisible, mysterious force, then show me space-time, because I can't see it.
FYI, space-time is conceptual. Betty?
But you can see it.
Or you can think of it as real, or potentially bendable, but it's conceptual. Betty?
Yeah, I want to see the wizard with these mysterious and mystic forces. I want to see that.
Yes, we all want to meet the Wizard of Narnia, but
Yeah, the one behind the curtain.
yeah, but space is fake, so alas. Adam?
Just a quick question. So, John, there isn't a mystical force between objects at distance interacting then?
I don't know how many citations I just gave you.
Yeah. I'm just thinking. I'll just to confirm that wand is definitely snapped. Then there's numerous from various sources, not just Georgie Buckamusa, who's citing it. You know what I mean? These are all from credible sources you cited across the spectrum of the physics world that are all quite categorically stating it is not a force.
And guess what we're going to hear tomorrow? The force of gravity.
There's nothing else. There is one comment I've actually got, if you don't mind. Can you go back to the quote from the New Scientist? It spoke of falling around suns or words to that effect. Here we go. You want to read it, if you may?
Yes. So although Earth appears to be pulled towards the sun by gravity, there is no such force.
So that was probably the only exception, but that actually had the presupposition that we are falling around the light in the sky. See, traversing the sky.
Yeah, it's the only one that made any connection to anything outside of it. Yes.
No worries. Just wanted to make that clear to anybody who may hang on to that particular part of it, that is entirely based on a presupposition that Earth is a sphere and the sky is a vacuum and that we are falling. That is the presuppositional sphere. Earth is falling around the light that we see traversing above our head.
I want to make a correction. I said tomorrow we're going to hear force. It's not going to make it till tomorrow. It's going to make it to the when we go to Discord.
Well, that's a nice segue. So there is a link below this video if you do want to join. I think there is some gaps still left on the Discord panel. I can't see it in the tiny little OBS box, but yes, I believe there are some gaps left. If you did want to join and ask some questions, we will open this up to the public towards the end of the presentation. So just FYI. Do you want to continue, John?
Yeah, let's roll.
You're up.
So the Reverend John Michelle Cavendish CV boys and Weird Al's gravity are not the same. Number one, scientific theories never, ever, ever explain laws. You tossers. Newtonian gravity and Einstein gravity are mutually exclusive. Listen, if a scientific theory explained the law, then that law wouldn't be a law anymore. Okay? And since you guys are all on, I've heard so many people say this. Listen, I want to hear it or see or post a citation of the theory of the laws of thermodynamics. Can I see that? Because that's essentially, by analogy, what you're saying here. It's quite preposterous. Number two, Newtonian gravity is a force. Remember this from above? Einsteinian gravity is not a force. Number three, Newtonian, the law of superposition applies. Einsteinian, the law of superposition doesn't apply. Number four, they're not even in the same geometry, for crying out loud. Newtonian gravity is Euclidean 3 space, whereas Einsteinian gravity is pseudo-Riemannian 4 space. Newtonian gravity is instantaneous actions at a distance. Einsteinian gravity is limited to the speed of light. Listen, drunken sailors and field goal posts have more in common than Newton's and Einstein's fairy tales. Just to let you know, I'm still using Newton. That's just for everyone, so everyone can identify what we're talking about here. We're going to slowly transition over to CV boys over the next few months. So why on earth are you still appealing to Newtonian, Cavendish, CV boys, John Michelle gravity? All that these crayon munching wiki parroters are doing is taking an effect. Things fall to the ground at 9.81 meters per second, which is bullshit, like I said before, and then conclude by mere declaration gravity is the cause. It's a non sequitur fallacy on its face. They use this value, again, 9.81 meters per second squared, which is bullshit, and put it into their fairy tale descriptive equations and say it works. Then they say, voila, gravity exists. The attribution or cause of this effect has not been identified, isolated. That is scientifically validated. So every time you say gravity, whether you like it or not, as soon as you say or pose gravity, you immediately invoke a cause, either mass attracting mass or space-time, right? So you need a new word. I got one, Ducal Slopelgerts. Clowns. So mass attracting mass, the hypothesis, and this one cracks me up. We hear, how many times have we heard this? Well, they don't say it. We have to get them, we have to hold them by the hand and they finally get to it. If mass, that's the hypothesis. There's a hypothesis. If mass, then mass attracts mass. That's what it is. It's so hilarious right on its face. I mean, it's a Mr. Magoo circle jerk of the millennium. Independent variable, mass. Dependent variable, mass attracts mass. Yeah, nice. Clitus Venetas. This is your actual hypothesis. If gravity exists, then larger masses will attract smaller masses. Even though you can't define mass, we're going to get to that here in a few minutes. This is an affirming the consequent formal logical fallacy on its face. If P, then Q, Q, therefore P. Have a nice day. P.S. You'd fail 5th grade general science. Let's stop right there. Questions, comments?
And mass doesn't attract mass.
And what is mass?
You got. I was on mute. You're lucky. You're faster than me.
Go on, you can go first then, Betty.
Yeah, well, we had a guy in Discord also going over mass and moles and stuff. It's so convoluted that nobody can really define mass, and they get stuck in these terminologies, and they still don't want to use it. And if you can't be certain what mass is, how can you use it in an equation? Whatever equation.
Okay,
So-
but whatever they'd like to define it, with the exception of inertia, you know, stuff doesn't attract other stuff. Just in nature, I'm not seeing boulders attracting boulders or anything like that. That doesn't happen. That was my point. Yeah, I get you. They give a, I've forgotten the fallacy now, equivocation fallacy, correct?
Yes.
So they define it in many different ways. But, Paula?
All I know is that math attracts math.
Math attracts math.
Yes.
Yes. Maths attracts maths. I almost snuck a mass in there.
I
Hey.
got your joke for the geeks.
Hey, be careful before. Wait a second, Adam. Be careful because you said what attracts each other in nature. We just talked about that before.
Yeah. Birds.
Birds humping.
Ah, right. That's the attraction. I see. No. Adam?
You're getting into mass in a minute, I assume, John. Yeah.
Yes.
Yeah. All I'll comment on is that, again, I think Isaac Newton would have been offended by the way in which the phrase Newtonian gravity was used in those previous descriptions. I'm sure he made it quite clear that wasn't his point.
Okay, so this is the... are we going to start explaining things for ballers now? Should it be baller time to pay attention because we're going to talk about mass? Or is that later?
They should have been paying attention the whole time.
Oh, yeah, but you've got to actually tell them when the main bit of their ingredient that they need to argue this point is coming up, and I think it is. Yes, I've got it on screen. Go ahead, John.
All right, please define mass because you know that's what's going to happen every time they come on. You're going to hear somebody say, well, define mass. And in the beginning, they used to, complain about, oh, it's all semantics. It's just semantics. They've stopped doing that recently, but I'm still going to keep this in here because I think it's important. So, yeah, it is semantics. Because what is semantics? Word definitions. That's how we communicate, right? That's the Socratic method. You have to define terms, or I could be talking about an apple and you're thinking about an orangutan, right? So we have to define terms. From Anne-Marie Helmestein, PhD, Biomedical Sciences from ThoughtCo. Words have precise meanings in science. From Dr. Mary Schweitzer, paleontologist, North Carolina State. Exactly. That's one of the things I drive my students crazy on. Words count. Words are important. Choose your words carefully. So that's what we're going to do. Here we go. So what do we get? The mass definition. We got problems already, right? Because we have two different definitions for the same thing. Both of these are from Wikipedia, their alma mater. Mass is both a property of a physical body and a measure of its resistance to acceleration. A change in its state of motion when a net force is applied. Ruh-roh, Shaggy. Inertia is the resistance of any physical object to any change in its velocity. This includes changes to the object's speed or direction of motion. These definitions, folks, are the same friggin' thing, just dressed up a little bit differently. But as you can see, the same friggin' thing. Then the Elmer Fudd sophists try and weasel their way out here with velocity and acceleration. The velocity of an object refers to the speed in a specific direction. Velocity is nothing but the rate of change of displacement. On the other hand, acceleration is the rate of change of velocity with respect to time. So acceleration, units of measure, meters or distance over seconds squared. And velocity, units of measure, meters of distance over seconds. If you're traveling at a constant rate, you have velocity but no acceleration. If you're traveling and your rate is changing, you have velocity and acceleration. This is lovely, but who friggin' cares? This is the compelling factor in the matter. If something is accelerating, does it have motion? Yeah. If something has velocity, does it have motion? Yeah. That's it. They're the same. It's over. Definition of mass number 2. Look, we got serious problems with equivocation fallacies. You guys need to look up what that term means. So, from New York University, mass is a measurement of the amount of matter something contains. Ruh-roh, Shaggy. From Chemistry World, the mole became part of the International System of Units, the SI, in 1971. Currently, it is defined as the amount of substance that contains as many entities as there are in 12 grams of carbon-12. These are the same, right? These are friggin' the same. Just because mole is a specified amount of substance that contains doesn't nullify the fact that each, i.e. mole and per the crayon munchers, mass, are entirely based on amount of matter, substance that something contains, right? By the way, from the Royal Society of Chemistry, moreover, studies have shown that the amount of substance is often incorrectly identified with mass. This ends it. I mean, I just could have posted this and been done with it, but where's the fun in that? And by the way, the new they recently redefined the mole. It contains exactly 6.022140076 times 10 to the 23rd elementary entities, not carbon-12. Just to let you know. The tangled webs you mindless parroters weave. Let's put an exclamation point on this mess. What is Mass by Edwin Taylor and Professor John Wheeler. Nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term. Even if we could count the number of atoms or by any other counting method, try to evaluate the amount of matter, that number would not equal mass. Do you guys get it? Doubtful. Questions, comments?
Oh, I remember this, John, from early days at uni, as a young buck with all these ideas presented to your university professors, and I always remember being told, Adam, you're going to be a chemist. Forget it all. It's all physicist nonsense. Weight is mass. You live on the earth. And leave it alone, because it's just a head bender for me that the only reason it's there is to try and make what we experience in reality weight, and not their definition of it, but what something weighs, as to try and turn it into some multiple of 9.8 meters so that it can be convoluted. But like I said, for me, it was always explained, leave it well alone. You're a chemist. Just it is what it weighs on your balance. And I've never heard a definition I agree with regards to mass either.
Yeah, because there isn't it. Yeah, because there isn't any. That's
with
why.
With regards to moles and people's familiarity with the term moles are a useful way of calculating things for outcome, but again, they're not in any way anything other than a unit. They're not a definition of mass itself. They're just another way of. They're just another unit, like grams, kilograms. It's just a useful way of calculating things when you're dealing in very small numbers. It's a way of, because you're able to multiply it, you know, so it's just a way of dealing with small numbers simply. It's just another, let's say, another unit, not metric, but another unit.
Yeah, you're calculating a certain amount of matter or substance.
Yeah, but it's just another way, particularly in biological systems, that it's just another nomenclature for things. It isn't anything other than really any different to any other measurement. It's not anything unique that is, yes, it is linked to the atoms themselves, the number of them, or theoretical number of them, and that's the point. It is, again, a theoretical derivative, this, based on calculation and the concept of a model. But in of itself, the point with the mole is it doesn't lend to any definition of mass.
Right. It's just a convention.
Yeah.
There's nothing wrong with it. You need more. You need this in chemistry and biochemistry, for goodness sakes. But the key part, it's a certain amount of substance. Right? Amount of substance. It's just a certain amount of substance. Just because it's a certain amount of substance doesn't disannul the amount of substance to which you knuckleheads appeal to. I hope that's getting through. I doubt it.
Paula, have you got anything you want to add before we move on with the presentation?
Yeah, just that the equivocation fallacy isn't the only fallacy going on between mass and inertia. It's also self-contradictory. As someone pointed out, I forget who it was on a panel in the last week or so, said that since mass is basically inertia, resistance to change of motion, and gravity is mass attracting mass, they're two opposite things. Is it resisting or attracting? So I think that was a good point that I can't remember who brought it out, but it is self-contradictory. It isn't just that they are changing terms without any objective difference between them. It's because they're two opposite, mutually exclusive things. Is it resisting or is it attracting? It can't be both at the same time.
Betty, there?
Yeah, I'm confused with all these terminologies and stuff. But I'm also stuck on the word substance now. So what's the substance? Is that the dirt? What are we talking about?
Well, the substance now, they've redefined it. The new definition is that number with Avogadro's number with elementary entities. It's not based on carbon-12 anymore.
Okay, so it can be any kind of molecules then?
Elementary particles.
Okay. It opens up for more and more questions, I think. But yeah, I don't know what it is still. So with all these definitions, we get more than we can muster, and we still don't know what it is. So
I'm with you, Betty. I remember when the definition changed. I think it was either very early 19 or back in 2018. I forget when, but when John did one of the presentations, it was in the transitional stages, and he had to explain it to me twice, and I still don't fully understand it. You know, someone's quizzing me in the chat saying, you know, go back to the definition of it with C12. And I'm like, well, that isn't the definition anymore. I mean, John has gone through it once already, and I'm sure it will obviously come up again. Quite why, I don't know, but there we go. You know, I'm with you, Betty.
Yeah, and if they can change it that easily, what was it worth to begin with? And what will it end up in? And
Well, yeah, that was the next thing, but exactly.
Like I said, it's just a convention. Don't get all bent out of shape over this. The important part, it's the amount of substance, right?
Mhm.
Sure,
That's
it's
the important part that connects both definitions.
right, exactly, to bring it back on track. In terms of mass and mole, it's the amount of stuff. It's just that simple.
Precisely.
Okay, do you want to... I'll bring your presentation back up. Let's move on.
All right, let me give a warning right now to all the ballers. Listen, you guys should turn away. If you're going to listen to this and watch this, then I suggest to get your friggin' therapist on the line with you, because you're going to need it after this. You ready? Listen to this closely. Professor Sankar, Chair of Physics, Yale. The laws of physics are always quantum mechanical laws. You don't have separate laws for big and small things. Okay? Let that sink in. The laws of physics are always quantum mechanical laws. You don't have separate laws for big and small things. So, and it's going to happen. It's probably going to happen later. That quantum mechanics doesn't apply to big things. I'm telling you, somebody's going to say it. Unbelievable. Now here comes the really painful part. From Richard Feynman. Listen carefully. The discovery of quantum mechanics first, and then in the behavior of light, and then in the behavior of matter, finally culminating in 1926 with a full equation of quantum mechanics, which told us that the laws of motion of Newton were not right. Let me say that again. Which told us that the laws of motion of Newton were not right and had to be modified with other laws, which are quantum laws of motion. Did you all get that? Let me say it one more time. From Richard Feynman, the laws of motion of Newton were not right. From the chair of physics at Yale again. All right, so today we're going to shoot down Newtonian mechanics and Maxwell's theory. We're like the press. We build somebody up only to destroy them. First, I want to tell you, this is again Professor Shankar from Yale. First, I want to tell you what goes wrong with Newtonian mechanics. The double slit experiment is a problem. That's what puts the nail in the coffin for Newtonian physics. Now, like I said before with citations, these citations are all well and good, right? And they come from certifiable characters. However, they are merely baseless assertions at this point. So get ready. Here comes the cowbell. Ready, clowns? So we have a double slit experiment with a Newtonian particle, an electron. We close one slit and fire a bevy of electrons and we get 10 hits at point A. We close that slit and open the other slit and fire a bevy of electrons and get 8 hits at point A. The Newtonian prediction would be if we fired the same bevy of electrons with both slits open, we must get 18 hits at point A. What do we get? We get a big fat 0. And what does that mean? That is the end of Newtonian physics. I don't know. What does this mean? That is the end of Newtonian physics. Must be a mystery. Let's get our abacus out. So, in relation to Newtonian or classical mechanics, that's what you're going to hear. Every time you hear classical, that's Newtonian mechanics. What does shoot down the nail in the coffin, destroy, that is the end of, and the laws of motion of Newton were not right. What does that mean, Baltards? What is particularly confusing about this? Have a nice day. Questions, comments?
Hey, I put on my globe head hat and all I heard was la 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 while you said all of that.
That's a good technique.
It's not so much a globe head hat, but maybe a lack of understanding hat. The first citation is to make a statement as to equilibrate the laws of quantum and the real world. There's no difference. And then the second part uses a quantum experiment to destroy Newtonian mechanics. And I just wondered if you could just elaborate why that experiment destroys Newtonian mechanics a bit.
What do you mean why? The Newtonian prediction would be if we fired the same bevy of electrons
exactly
with both slits open, we must get 18 hits at point A. Yeah, that's it. That's why. But we don't. There's my explanation.
You know what they'll do is just play the quote mining cherry picking card. And around we go.
The quote mining? What quote mining?
They'll just, you listed all those quotes, about the nail in the coffin and all that, and they'll just say, quote mining.
Yeah, they don't know what quote mining is, and we already established they have no clue what cherry picking is either. So I love it. I love it when they do that, especially when they haven't read any of the transcripts or documents that I've put in here and say quote mining. That's priceless. It's special.
See, you there?
Yeah, I have nothing to add to this. We get into difficult topics anyway, and we had a presentation on this already, so you can always go back to that one.
A Sleeping Warrior has a question in the chat. If gravity is not a force, what is causing tides if it isn't the gravitational pull from the moon?
Invisible three-toed gnomes.
Right, I've got you back on screen.
Why'd you snicker? Why'd you snicker at that? My explanation is just as scientifically valid as any of the ballers' explanation, right?
I was laughing with you.
Okay, let's go over this real quick. As I said, the mindless retort from the pummeling up here is quantum mechanics doesn't apply to big things. Remember, I laid the groundwork, the foundation before we started? I'll say it again. From Professor Shankar, the chair of physics at Yale, the laws of physics are always quantum mechanical laws. Here's the important point for you. You don't have separate laws for big and small things. It ain't going to matter. They're just going to bring it up again. From Lapquicks, experimental non-classicality of an indivisible quantum system from Nature. Our results illustrate a deep incompatibility between quantum mechanics and classical physics that cannot in any way result from entanglement. So like I said, this is the key word right here. Classical, this is Newtonian physics. Late last year, Bruckner and Koffler showed that it does not matter how many particles are around or how large an object is. Quantum mechanics always holds true. The reason we see our world as we do is because what we use to observe it. The human body is just barely adequate measuring device. Quantum mechanics does not always wash itself out, but to observe its effects for larger and larger objects, we would need more and more accurate measurement devices. We just do not have the sensitivity to observe the quantum effects around us. From the Bulletin of the American Physical Society. The current record holder for quantum interference is 10,000 atomic mass units. We're well beyond single photons and electrons here, folks. And I love this one. A metal paddle 30 micrometers long, that's trillions of atoms. From nature, a team of scientists has succeeded in putting an object large enough to be visible to the naked eye into a mixed quantum state of moving and not moving. Goodbye, Newton. Sing it with me now. Turn out the lights. Party's
over.
They say that all good things must end. Call it a night. You get it?
I think that last point probably exemplifies what I was trying to make out previously. So Newton's stuff works on the big scale. I'm trying to get this right, John, in my head. So just humour me a minute. So Newton's stuff works on the big scale, but it doesn't.
No. Got it wrong. It appears.
Yeah. Let me get there then. Let me get to the end of the sentence. It appears to work on the big scale. Clearly doesn't on the small, and is not applicable. The converse for quantum is it works on both scales, but we've got an issue in terms of being able to validate it up to scales. But we have achieved something which demonstrates quantum behavior on the visible scale, therefore destroying classical, demonstrating that the classical in of itself is clearly incorrect, because whilst it might have been in some cases a good approximation, it doesn't actually represent what's going off, and therefore.
Exactly. You got it. Yep.
Oh.
Okay. Well, I don't know if there's a bit more to your presentation, but ladies, have either of you got anything to add?
No, not really.
No.
Okay.
It's gonna end here real quick.
Okay.
I'm just gonna go briefly over Einstein. We're not gonna go over everything, but we're coming close to the end.
Okay, well, I'll do one last plug to the Discord server then. So if you do want to challenge anything that's been said, ask any questions or anything to that sort of fashion, then there is a Discord link in the info box below this video. Feel free to join. We will come to the Discord server once the presentation's over, and we've got a few remarks from the Ballbusters team. You're on screen, John. Go ahead.
Yes, like I said at the beginning of the presentation, I'm not going to go over the grown-up falsification. I'm just going to go over the primary school falsification for Einstein, both special and general relativity. I have it in here. I have the whole grown-up falsification, but like I said, we're not going to go over that. Go back to the last gravity presentation, and it'll have the whole spiel in there. Okay? So, relativity, special relativity and general relativity, via different mechanisms, speed versus gravity, can dilate, bend, warp time? Are you kidding me? The primary school falsification. Time is a conceptual relationship between two motions. Specifically, it's based on alleged single rotation of the Earth on its axis in respect to the sun, a day. It's a concept, non-physical. It is without chemical formula, structure, charge, mass, momentum, or spin. No millielectron volts, kcals, or kilojoules. No dimensionality or orthogonality. And no direction or location. You can't put time in a jar and paint it red. I mean, come on now, let's reason together. Can you dilate, bend, or warp non-physical concepts? Is it your contention that if you have poison ivy on the brain that you could scratch it by thinking of sandpaper? Freedom is a concept also. Can you bend that? That which you are using to measure isn't the thing that you're measuring. A football field is 100 yards long, but a football field isn't yardsticks. If I bend the yardstick, does the football field bend also? So if something affects, say, cesium atomic clocks, or any modern clock for that matter, does that then ipso facto mean the Earth's alleged rotation in relation to the sun is affected? These two mythomathematical fairy tales, special relativity and general relativity, were falsified 30 seconds after their respective publications by third graders at recess, for goodness sakes. In toto, Eat your massive reification fallacies on nuclear steroids. So, like I said, we're not going to go into the quantum mechanics pummeling, but we'll just take a look at these two because these two do the job. From David Bohm, renowned professor of physics and a personal friend of Einstein, by the way. One could see that relativity and quantum mechanics, the two most fundamental theories of matter, really contradict each other in the sense that relativity is local, it's causal, it's determined, it's continuous, and quantum mechanics is just the opposite. You couldn't get any more different. From Caltech, the final contradiction. General relativity and quantum field theory are incompatible. I don't know what else to say here. I can't break this down any further. So it's time to wake up, pretender clowns. Thanks for your ear. Have a nice day.
That last quote was an interview then.
Which one? The David Bohm interview? Yes.
Wow. Imagine saying that. I wonder what the question that preceded it was.
No, I can't remember. You know, in fact, this is old. We're going old timey. I think this was David Suzuki. I think that's what his name. Remember back in the day when they used to have interviews with scientists on, and I don't even think it was called Nova back then. I think it was just PBS did them. I'm not sure it was so long ago, but I can go ahead and we'll wait till afterwards. I'll go ahead and look this back up again. I'm pretty sure it was that Suzuki character.
Paula, you got any closing remarks, and then we'll go to the Discord server.
Not other than to say again, as he just stated, that this is a reification fallacy to make time the cause of anything. I don't know how many times somebody in chat keeps insisting that a car moving at a certain speed, which presupposes it's in motion, is going a certain distance because time is the cause. I don't know what else to say about that.
Yeah, we had that recently from, was it Sean Hufford? That said time was the cause of all things, basically.
Yeah. It's the magic wand. Time plus nothing equals everything.
Indeed, it's the independent variable to end all independent variables, right? I'll come to you in a minute, Adam. Betty, have you got anything to add?
No.
Closing remarks, because we're going to go to the Discord server soon.
Closing remarks. Oh, that, yeah. Well, here still people say that they change it a little bit with now that gravity is not a force, but it causes a force. So the time bending concept is causing a force. That's what we hear. And on this topic with the marrying quantum physics with general relativity, that it's all mathematical that they try to do this. And the other high studied people that are trying to marry these two bachelors. But yeah, I give them
it's the ultimate conundrum, isn't it? Because you've got gravity is not force, and the bending of a conceptual medium known as space-time gives rise to a non-force known as gravity.
Yeah.
Isn't that an amazing story? Luke, the force is with you. Adam, you're going to get the last words before we go to the
that's
Discord
actually
chaos.
A perfect link, Nathan, to the point I was going to make. It's post-Einstein and all this nonsense, you know, the mainstream media, the main sci-fi thing has been to try and turn time into a not just this conceptual medium, but into something of substance that we can all start to imagine. We can time travel, we can bend, we can manipulate time. It isn't something just imagined, you know, that we perceive. And I think that's integral in our acceptance as we move from one bullshit paradigm of a force, a magical force between two objects. The only way to keep the heliocentric model together wasn't to subvert back to reality, but was to kind of, a bit like the Big Bang, shift the goalposts and move any point of argument, discourse, or conjecture and criticism about it into this new imaginary medium where you can do whatever you want with maths in it, because it's completely imaginary. Unlike height, depth, and breadth, which are at least real, this medium that they then start to manipulate their proof of their modeling is completely imaginary and undisprovable.
Right. I can never quite say it correctly. Pseudo-Ramonian, I think, is the correct term.
Yeah.
Four space.
Pseudo-Ramonian four space. Yeah, it's a completely different geometry than Euclidean.
Indeed. Right.
Built out of
Yeah,
solid
yep.
bullshit.
Yeah, so I have one last comment before you end, unless you want to end with it, Nathan. I just want one last one after you're done.
So do you need me to present you?
Yes.
Yeah, you're on.
Okay, folks, this is what we got now. This is the hierarchy of pseudoscience quackademia. And what I mean by that, I'm talking about paleontology, archaeology, anthropology, geology, evolutionary biology, whatever that is. Yes, I'm still laughing. Theoretical physics, astronomy, astrophysics, and cosmology. This is the picture right here. They're all pretender clowns, the hierarchy. And if you listen to pretender clowns seriously telling you about the nature of your reality, then you become one of these. It's a very strict metamorphosis. And we see it every day. That's all I got.
Okay, I don't know if Betty wants to jump in on Discord so she can hopefully control some of the chaos. But we've got Kosal. Oh, let's move my mic so I can introduce these people. Is it El Brocchia, Pinocchio, Righteous Force, Right the Hand, and a couple of others, Zanek, and I can't. Too many syllables. It's too late in the UK.
Unusual veracity.
That's the one. It's the one I said the same thing to you last time. My screen's quite some distance. That's my excuse. Okay, right. You take charge, Betty. Unmute whoever you feel necessary, and then just introduce them so they know they've been unmuted, if you would.
Yeah, I've unmuted Unusual Veracity because he was here for the beginning. So maybe he wants to talk or can talk. So, no.
No worries. I don't mind if this slows things down a little bit. Obviously, I want the public to have a right to reply on these shows, so.
Mm-hmm.
Lost one. This is lost three. Are you lost two over?
Should I go to the next? Should I just try Pinocchio?
Well, that one there talks. Well, I can try. Maybe he will change his mind.
Go ahead, Pinocchio. You're unmuted if you want. If you got a question or anything to add.
Slap him in the back. Maybe he'll hack up that furball.
Well, I have unmuted Right the Hand. Maybe he wants to say something. Let's see if it works. Hangout.
Right the Hand, you there? They're all staying on mute. Might be a very short public part of the show. We'll see.
Well, we have Zanek, so that's the baller.
I'm just listening.
Have you got anything you wanted to ask Right the Hand?
Nope.
Oh, fair enough.
Okay.
Try Righteous Force.
It's unmuted.
Just get Zanuck to talk.
Yeah, he was toe tagged Friday though, so be careful.
Says Zanuck tapping away on his keyboard. Have you got something you want to ask, Zanuck?
Hello, everyone.
Hello.
Nice to talk to you all.
Have you listened to the presentation?
I did, most of it.
Okay, what's your thoughts?
Oh, he's usually right on with a lot of his basic definitions of, and I do have objection to some of the contentions to what we've been talking about, such as, and I don't want to go into the mass versus bull, just because that's so pedantic, it's unbelievable. But I think I found a word. I don't know if I mentioned this yesterday for that discussion. Any amount of matter is mass. That way you can narrow it down. Words do matter, right? So any amount of matter is mass. And a mole is a specific number. He said that very clearly. So I think we're all in agreement. We should move on from that. Do you not agree? The mole
Any
of hydrogen
doesn't
is 1 gram.
change
The
the
mole of
amount
gold
of
is 200 grams.
substance or the amount of matter, right? Your little any doesn't change anything.
Any is important, right? Because any amount of matter is mass. Any. One particle,
any amount of
1,000
matter,
particles.
right? That's a mole.
Any amount of matter is mass, yes.
Your amount of substance or amount of matter is the definition of mole.
No, the mole is a specific number or amount of matter.
Yeah, that doesn't matter. And I already explained that during the presentation. So rewind and go back to the presentation.
A dozen eggs? Okay, let's go to the next question.
You feel free. Go ahead. Ask another question.
Quantum physics? Quantum physics versus more broad Newtonian physics? They both. You're right. I might have misspoke yesterday saying they're different, and you're absolutely right by calling me out on that, because quantum mechanics does play a role in all things we see on larger scales. The problem is the scale of things that are larger are so much larger that it's difficult to apply quantum mechanics to most things in the Newtonian world.
No. Quantum mechanics doesn't play a role. The laws of physics are always quantum mechanical laws. That's the role.
Shout out to Tina Baker for hitting the super chat. Thank you very much indeed for your support.
Don't try to weasel. We're listening to every word that's coming out of your mouth. So you're not going to weasel here, just to let you know.
You're absolutely right. Everything's based on quantum mechanics. I agree with you. But if you were to use quantum mechanics to apply corrections to the spinning of a ballerina, you're talking about 100 zeros to the nth degree of the classical.
God.
Mm-hmm.
So now we're going from pulling rabbits out of the hats to ballerinas. Is this all you baltards got? How about shoes on top of the table?
It's an example of physics. And you're right, it does play a role, but it's a very small role.
What plays a role?
If you make the corrections in quantum mechanics to something spinning.
Plays a role?
Yes.
What plays a role?
A foundational role.
Oh my goodness!
Sorry, what plays a role? That's not a yes or no question.
Quantum physics is a foundational role of physics.
So what you're saying, it's kind of fundamental then, as opposed to a small role.
Absolutely.
Yeah, absolutely. We'd agree.
So
you understand that it's on a very small level. So those, yes, go ahead.
At a very small, fundamental, crucial to everything kind of role. Yeah.
It's a correction. Well, can you give me a quantum physics or quantum dynamics law or instance or example?
What do you want?
Give me an example of something that is fundamentally true in the world of quantum physics.
The collapse of the wave function is always ever sourced by the knowledge of the witch path information. How you like that one?
And then tell me how that affects a spinning gyroscope.
What?
What?
What the hell?
I'm just
saying. Hold on. Let me just give this for the audience in case they're thinking that made some logical sense. Right, someone lays out a recipe for beef stew, and afterwards you say, "Tell me how that relates to mowing my lawn."
Well, you have pushing, when you break it down to pushing the lawnmower and the force and the acceleration and the mass, all that, because you can still use that as well. you'd like. These are all observations. These are all phenomena.
So what, in the respect that every single law is a quantum mechanical law, you can somehow loosely relate it to this example specifically? Well, you can do that if you want to, but asking us to do it just seems nonsensical.
Well, I can't relate because it's too small of a factor.
Okay.
The wave theory in quantum physics is a very small correction to any Newtonian or Einsteinian observation.
Wave theory.
I see what he's doing. Oh, you go ahead,
Wave.
John.
Okay.
Wave theory? What are you talking about? Is that a physical wave?
Yes, like water, like the waves you see in water. Yes.
Are wave functions physical waves?
Wave functions are physical waves. Yes.
You gotta be on
No.
some serious medication. Do you know what? Oh, go ahead.
Why do you think they've got this word function afterwards? What do you think a function is?
Function is something that's said usually in math, and I know you guys don't believe in math, so why do we need to go there?
You said it very stuttery. Something used in mathematics.
Something used in mathematics.
And is mathematics reality?
But you're asking me about functions, and isn't that mathematics?
Yeah. So when asked, is a wave function real? You said yes.
I said the waves were real. You asked about the function.
Well, that's not what we're talking about. Yeah, waves are real. There's waves at the seaside, but that's not what we're specifically talking about. Right. Causes wave function collapse. That's very specific, isn't it? That's what science is like. It's strange that. Always very specific about their terminology. Weird that. My point being, when you talk about mass, it's very loosely defined with very, loose, several meanings. Anyway, in this instance, we've got the word function strapped on a mathematical term. So we're not talking about physical waves. We're talking about mathematical.
Okay, but you understand about quantum mechanic waves, right?
What, probability distribution?
Yes.
Right, so not physical. What? They're not physical, okay? Hello?
Okay, I'm just thinking about. I don't know enough about it actually. Get any deeper than what I just went.
Well, let's try again. What's a function? Is a function something physical? Is it like kind of surf a function?
No, you can't surf a function.
Right, because it's mathematical.
Correct.
So is a wave function? Am I going to get my surfboard out for that wave function or what?
If you're an electron, you might.
So I'm going to. Let me get it right.
No,
you think
right.
I can surf on a probability distribution?
It's a mathematical formula.
You think you can surf on a probability distribution? Really? That sounds like nonsense, my friend. No, you can't. It's not physical.
Okay.
It's a description of something.
Well, the quantum mechanic waves, as you know, don't correspond to any wavy motion of the electron. But why can't we see the effect within like larger objects, like two basketballs or other larger objects?
Well, you can. They've scaled up the double slit. You can. It doesn't just work with tiny particles like light, for example.
Yeah.
You can scale it up.
The scale is 10 to the minus 32 meters. If you scale up
Didn't I just already go over this in the presentation and talked about the human was a barely adequate,
You're right.
a barely
I agree with
adequate
you.
measuring device? I already answered this.
Then we're good. I agree with you, and there's no argument.
Okay, I was about to say, it sounds like we're all in agreement anyway, so...
Yeah, I agree.
Is there anything else, Zanuck?
And I'll be the first to admit I did not get my degree in quantum mechanics, so...
Fair enough.
So if you did,
we're all in agrement. It's all good. Happy days so
Okay,
far.
good.
You've been surprisingly conciliatory, Zanuck. It's been amazing. If we don't get any other...
what was the next question that the gal was just... I think she asked something before.
Thanks. You don't need to take over hosting the show, though. That's all good. I can still cope. Thank you. Is there anybody else in Discord that has anything to add other than Zanuck?
Zanuck, do you now concede that gravity is
Gravity causes a force.
Well, no, gravity is not a force. A not force
Correct.
doesn't give rise to a
Correct.
force. Let's just get that clear.
Gravity is the cause of the force.
No, gravity's
He
not a
says it
force.
causes weight.
I'll say it again. Just listen. I'll say it slower. A non-force isn't going to give rise to a force. Okay?
How are you classifying non-force? Are you talking about pseudo-forces?
What do you know? Do you know what the word not means?
I do.
Do you know what the word force means?
I do.
Now stick an A between those two.
Can
You're
ask
there,
you if
my
you were-
friend. You're there. That little chuckle, that was you understanding what I said. This is great.
I know what you said, but is it correct? Is it correct? Are you saying that the force is a pseudo-force or is not a
Oh,
force?
no worries. I can give you a quote from an astrophysicist.
Yes, and hopefully you understand what he said.
Yeah, no worries. I'll quote him.
His words have meaning.
Gravity is not a force.
Correct, and he is
George-
very correct. It
Well, there
causes
you
a
go.
force.
What's the problem? It's not
Because
giving rise to a
something that
force.
causes something is not the something.
Oh, he's got
something
very
that causes
triggered.
something is not
He's
the
now
something. Words
talking
matter.
over my every reply. Are you by chance a ball-believing zealot?
No, that's not true.
That's not my question.
A force is not. Gravity is not the force. Gravity causes the force.
No. I'll say this again. I'll say it even slower.
Okay, slower would make a difference probably.
Well, I've said it twice already.
But I've said it back to you. You told me gravity is a fake force or is not
Right.
a force. And I said gravity causes the force.
Yeah, and
There's
I
a
say
difference.
a non-force will not give rise to a force.
Can I ask you why you're calling it a non-force?
Because gravity is not a force. George Musa, 2019, astrophysicist.
Correct.
Didn't you
It
listen
is a
to the
cause of a force.
presentation?
It is not the force itself.
No, it's just not a force. I'll maybe if I say it
I-
another
I
way,
ca-
I'll
I
try it
caused
different.
the
Let me just
bike
try
to
it one more
move. I'm
time
not the
differently.
bike.
I won't use gravity because it triggers you to talk over me. So, right, a car is not a carrot. Do you understand that?
I am not a bike.
Right.
But I
And
caused the bike to
gravity,
move.
hold on, we're nearly there. And gravity is not a force.
Correct.
Right.
Gravity
Now,
causes
hold
the
on, I'm not
force.
quite there. I'm leading you. Now, a carrot is not going to give rise to a car. Because it's not a car.
It'll give rise to better eyesight.
Maybe. Now,
But it is not. But it is not eyesight.
now
Carrot is not
gravity,
eyesight, but it
hold on,
causes
gravity in this example is our carrot. And the car is the force. Now, in the same way, the carrot's not going to become a car, gravity's not going to become a force. Because it's not a force. Okay, sunshine?
Really? Okay.
That's really,
So
yeah, really.
Let's go to magnetism then. Something we all can relate to. Two
No.
magnets.
We're not talking
Does
about
the magnet
magnetism.
cause the force,
no.
or is the magnet
no,
the
no,
force?
no, 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 no.
Is the magnet
Let's
the
not-
force?
No.
Is the magnet-
No. Let's not equivocate. Let's just have
Well,
you
ask
repeat
the
it back to us, just at least once.
You've talked about carrots and cows, and I can't talk about magnets, really?
Not
Okay,
carrots
fine.
and
Can I ask
cows.
a question?
Carrots and cars. Cars. How is my English
Carrots and
accent that
cows?
terrible?
Carrots and something.
Okay, Zanuck, maybe go and get a cup of coffee. Calm down. I know this is a lot to take in, but gravity is not a force.
Correct. It causes a force.
No.
Can I ask Yannick a question?
No. You see, the carrot can't become a car, and gravity can't become a force because it's not a force. And not a force
can
doesn't
I-
mean it becomes a
Am I right about-
force
Am I the bike?
or makes a force. It's not a force.
I'm not a bike, but I can cause a bike to move.
That's lovely.
You're
I'd
using
like
false
to ask
equivalence.
the question.
Anyway, we're kind of done, Zanuck. I know this is a lot to take in. It's obviously
Let me talk to Tenth
stressing.
Man. He had a
you.
question for me.
Yeah, Zanuck, can a non-person cause anything?
No.
Thank you.
Has anybody else on the Discord server got anything to add?
I've got a quick question for Zanuck. What new force does the force that isn't a force that is gravity cause?
Of course.
Mass to accelerate. That's a great question. You laugh, but it's a great question. So this force that is caused by gravity causes mass to accelerate at a specific rate proportional to its mass.
I didn't ask what it did. I said, what force is it? I appreciate you're
It's a
just
force that
then
accelerates.
moving the effect of the previous force of gravity that isn't a force anymore into the new force with the same definition. But
The force
I'm
as in
asking,
Newton's.
what is this new force? What's its cause? What's its causation? Where
cause
does
is
it
gravity.
manifest from?
But before the
Are
question
you
gets
asking if mass
answered,
attracting mass? Is that what you want me to say?
I'm really
Yes,
sorry.
yeah.
Just before it gets answered, because I don't think maybe Adam, you don't understand. Gravity is not a force. Adam.
No. I thought we'd agreed that bit with Zanuck. I thought his supposition was that the non-force that was gravity was creating a force, and I was asking what this new force was that was created by the non-force that was a force. It isn't a force.
Force that
But you
causes
can think of it
acceleration
as
in
a
the mass.
My bad. I misunderstood your misunderstanding. Go ahead.
Say it over again.
I can't. Really?
No, I understood the question. He's asking what
The type, are you talking about the type of force it is?
Go on,
It's an attraction force. It's an attraction. That's the force.
Between
two
what?
objects. Two masses.
caused by.
I see what you're saying now. I got it. Yeah, it's an attraction. Such as if I punch somebody, it's a punching force. If I do the other things can be an aerodynamic force. This is a attractive force. So yes, you're absolutely right. Good question.
Okay, so when I go into a fight and I hit somebody,
No. Hold on. Before the Discord server get into Discord, right? Well, I'm just want to get clarity. So what you're saying is that gravity gives rise to an attraction between masses, a force, correct?
Correct.
Oh, yeah. Gravity is not a force.
Gravity causes the force. I gave you the definition of the force. What more do you want? I apply the force to an object, it accelerates measurably, predictably, repeatably. Based
What's
on
the
its mass.
hypothesis?
Yes, and I can give you evidence to that hypothesis to reinforce that it is
Okay.
measurable, predictable, and repeatable.
No worries, John.
Oh, hold on.
It would be a great way to round out the show because obviously Zanuck believes he has scientific evidence of gravity. Let's go. Happy days.
Hold on a second. Hold on. Just wait one. Let me share my screen.
Bring it up.
You know, we did this 3 times yesterday, and he failed each time.
That's okay.
You know that, right?
Because we got on the semantics direction, didn't we?
No.
I'm not going to criticize tenacity.
Go ahead.
Hold on a second.
I'll hide you again while you scroll to look for it.
Oh, we still have your last one up here, Zanuck. I didn't erase it. The half a mountain missing over distance.
Beautiful. Look at that.
Yes.
Yeah.
Love it. Everyone else loved it. Everyone else loves it too.
The Earth curve causes half mountain missing over distance. Yeah, that was a good one. Okay, let me get rid of these, even though I don't want to get rid of them.
Are you showing it on the YouTube or are you on Ballbusters? Or are you talking on Discord?
The public will get to see. Obviously, if you do want to watch this on the live feed, it's only a couple of seconds behind. But make sure you watch. You mute the watching page, the YouTube.
So
page.
you haven't changed it yet. All I have is your
forgot.
football
I
field.
usually erase them after the end of the show. I just forgot. I didn't want to punk you out or anything. It wasn't premeditated.
Look,
Me?
In all seriousness, look, this could be a big moment, man. I might have to change the housekeeping questions. That could require quite a significant amount of editing. And look, man, I'm scared.
Yeah, I doubt it. The fearless Nathan?
All right.
You kidding me?
Sorry, it's an inside joke.
It's just an inside joke, man. Don't worry about it. Go ahead. Natural phenomena. Observe, please.
About gravity, of course.
Mountain hidden behind curve.
No. Gravity.
No.
Bro.
Gravity. Come on, stay focused, Sonic.
Well, he said he was talking about the mountain curve. Okay.
Yeah,
Gravity.
that was the previous one.
Ball,
You are now on
object,
to
1
gravity.
kilogram
And you
object
said
falling.
evidence.
1
Hold on,
kilogram object falling.
you're being
at
rumpus by
9.3
Betty. Hold on, Betty.
Sorry.
Zanuck, we're hoping
Yes.
to get your, this. Let me get it straight. Adam did clarify it earlier. This not a force giving rise to a force that causes the old-fashioned mass-attracting mass force. Correct?
Correct.
Right. What's the observed phenomena here?
1 kilogram block falling 9.8 meters per second when dropped.
Hold on. Sorry, John. I know you're still writing it down. You've got the cause in there.
The observation is something falling at 9.8 meters per second squared.
You missed off 2 words that you had earlier. You had 2 extra words in there.
Oh, I gave the weight. I gave the mass.
You
Sorry.
said
when dropped.
When dropped.
When dropped.
Oh, well, there's your cause.
That's still the part of the observation. I drop something and accelerates at 9.8 meters per second squared.
Yeah, cause and effect in one statement. That's my point.
So by dropping it, I caused it accelerating.
Yeah, there's your cause. You dropped it. Presumably, you had to pick it up
should be able
first.
to drop.
Hold
You
on.
wouldn't need to find the cause then, right?
You've got no
you
need
dropped
for. There's no need for science here. You've already got the cause.
So
Hello?
I drop something, and it causes.
You started. Your first word was the cause again. You
That's the
dropped
cause,
it.
really?
Yeah, you dropped it. There's your cause, my friend.
I can change the variables.
Okay,
Yeah, but
let me just ask him one more question, and then I'll pass it to you, Betty.
Okay.
Sorry. Do you find hovering in midair a 1 kilogram weight to drop, or do you have to remove it from its equilibrium and force it into disequilibrium prior to you dropping it?
That's actually a correct way to look at it, Nathan. That's actually very true. You have to move it.
There's your cause.
Hold on. So my cause. So that means I picked it up, and it required a force to lift it up a distance, which gave it. I had to consume energy to make that force over a distance. So
This
now
is
I have
very
an energy
exciting.
potential.
Look, this is elementary stuff that I'm sure you might be grappling with, but it's not very interesting for the audience. Yes, you going through the motions of figuring out how to pick something up isn't interesting. It's not very interesting. No offense.
Yeah, but let's not get bogged down by picking up and people picking things up. Let's do the apple which falls from the tree. That's a natural phenomenon.
But the tree had to grow.
What was that? I didn't see what you said.
The tree had to grow. It didn't magically appear from nothing, Betty. You know as well as I do that trees don't just render themselves.
Through osmosis and fusion,
but it is still a
material
phenomenon. We see an
around
apple
it.
drop. Even Newton
Xanax
was contemplating it.
He's ruining a perfectly good quantum mechanics joke. Damn it.
Stop rumpusing Betty.
Go ahead, Betty. You want him to go ahead with the apple?
Do it. I want to see what he makes of it. I mean, come on. Let's get him to do this.
Well, yeah, let's stick with the one that he's doing. When I drop a 1 kilogram block, it accelerates at 9.8 meters per second squared. That's what he said, correct?
Let's broaden the observation. Let's say we pick up the 1 kilogram block up 1 foot, and then we drop it and watch it fall. That's the observation.
Yeah, they're letting you have it now. They've overruled me, Zanuck.
Because we want to get somewhere. We're getting hungry. Okay. So that's the dependent variable. The 1 kilogram block accelerates at 9.8 meters per second squared. What is the cause, i.e., what is the independent variable?
The force due to gravity.
But that's what you're attempting to prove.
No, we're proving this something that falls when I drop it.
It's a begging the question fallacy. You're
Hold
trying
on.
to prove gravity. That's not your independent variable.
No. That's not what he said. He just said we're trying to prove something drops when I pick it up and drop it. Oh my god.
At a specific rate.
Sorry,
and with a
it's what I said
force.
originally. You don't need science for this. You pick it up, then you drop it, cause and effect in the original statement. It's all there,
Observations
mate.
were made in the early days and that didn't have science. They still observed them. Then later they used science to prove why they happened.
What happened? Why when you pick something up and drop it, it drops? Yeah. Had you not picked it up and dropped it, it would just be sat there. We don't observe 1 kilogram weights naturally falling. You know what we do observe naturally? We observe them in equilibrium. That's what we observe, right? Until you come along. So, yeah, you just rumpusing me. Until you come along.
You're right.
What an asshole. Gotta close the Discord line
Nathan,
just
could
to
I
make my
just
statement.
add
Until
one other
this
bit
guy
to that?
comes along, the 1 kilogram weight's not doing anything. We do not observe 1 kilogram weights flying through the air towards the ground and go, look, let's measure the effect. We need to establish the cause of this 9.8 meters per second squared because bloody hell, there's raining 1 kilogram blocks. We've got to explain this shit quick. No, they're in equilibrium until you come along and take them out of equilibrium and then start asking questions. So you remove yourself as the cause, even though you very overtly state it right at the beginning. You pick it up, cause established.
Yeah, and how do I wiggle that force of gravity? How do I
Everything
manipulate
has
that?
equal and opposite forces acting on it. Unless there's a disparity in force, nothing moves. So everything's in equilibrium. You're absolutely right.
Yeah, problem solved. So we don't have disequilibrium to measure and figure out as a phenomena until you come along and start forcing things out of equilibrium and then saying, oh, what causes this to go back to equilibrium? Hold on a second. Why was it out of equilibrium in the first instance? Oh, you, the cause of that shit that you want to now attribute a downward force to, surprisingly. I wonder how many times you'll make this example with a helium balloon.
Same principles. You have buoyancy force being greater than the downward force due to gravity.
There's another force.
How many
It's always
forces
a
are
balance.
there?
There's always forces in pairs. Always.
So let me get it straight. You'll presuppose the force of up, right?
You
But
can
the
measure
force.
it.
Hold
You
on.
can measure the
Hold
force.
on. He just doesn't like it. Fundies, man. So you'll presuppose the force of up. Call it buoyancy. And then what's the cause of buoyancy? Oh, it's gravity. Well, what's gravity? Well, it's a non-force that gives rise to an old-fashioned force of mass which you can't define. You equivocate it with both mole and inertia and its attraction. And where's this observed? In an old-fashioned circus show.
I
Shake
still
the apple
don't
tree
know
and it falls.
how you are going to manipulate that force due to gravity.
I don't have to manipulate it. It's based on the mass.
The what?
Yeah.
He says he doesn't have to manipulate it. It's based on the maths.
Oh, wow. Okay.
To
Why do I
manipulate
observe
it.
that?
Why wouldn't
math?
you try to do that?
I could change the force. Yes. Oh, you're right. I can manipulate the force. Sure.
Luke,
Hey, Zach,
let me know how you
said
manipulate
gravity
the force. Hold on, we got Luke
I
Skywalker
can
here.
change the force.
Tell us how
I
you
can change the
manipulate.
force acting on the apple. Yes, I can change the
How,
force.
how can you do that?
I can put a string on it and pull it down with a pulley.
Let me get it straight. You do it. It's always-
He's gravity.
Yeah, he is the force. Basically,
Gravity.
yeah. We all have the force within us to pick shit up and drop it. It's amazing.
And that's that agent.
Zanuck, you said gravity causes the force. Do you still believe
Gravity does cause the force. You want me to
Okay,
change the force? Cause the gravity?
okay. All right. So when you put the string and pull it down, are you gravity?
That's
No,
what I
I'm
said.
adding a force in addition to gravity.
In
Also,
addition to
force
gravity,
and
it
a
also is a
force.
force.
That's not really a force.
Another force, yes, another force. I've had a bottle rocket on it, and I can accelerate it faster than gravity would accelerate it. Increase
Okay, listen, guys, listen. On behalf of the audience, I would like to request mercy on Zanuck.
Indeed. I think this is probably going to be my useful opportunity, unless there's anything that you Ballbusters want to add.
Well, maybe John can read the hypothesis back and just give an overview what we got now.
Sure, yeah. Am I still screen sharing?
Yeah.
Yeah, so natural phenomena observed from Zanuck. When I drop a 1 kilogram block, it accelerates at 9.8 meters per second squared. The alternative hypothesis, the force due to gravity causes a 1 kilogram block to accelerate at 9.8 meters per second squared. The independent variable, the cause which has to be varied and manipulated, is the force due to gravity. The dependent variable is the 1 kilogram block falling at 9.8 meters per second squared. The evaluation is the force of gravity is what he's attempting to prove. So that's a begging the question fallacy. We can end it right there. You can't vary and manipulate gravity because he don't know what it is. Nobody knows what it is.
I say it's three-toed gnomes.
Yeah, so this is not. This is invalid to at the least. Just for a mercy, just to have mercy. This is invalid.
Yeah, overall, it's a begging the question fallacy. But Paula and Adam, we're going to round out the live show, and I'm going to ask people if they're watching on the Nathan Oakley channel to stay tuned. But do you want to round out anything before I close out the live show?
I'll stick a bit in. Cheers again, John. Another nice bit of presentation, mate. I don't think you've got a touch of the Mick West there. You've gone a bit shy on it. I see you've added something at the bottom of your calculator, your non sequitur tautology test. So
that's been there for a while.
We just don't often get that far. That's the problem with that.
Well, I just noticed it. I like that, mate. But no, cheers for another good evening, gents and ladies. Thanks.
You're welcome.
Paula, you can get the last word, then I'm going to round out the live show.
I think Paula's at dinner.
Oh, she's disappeared. Well, that's going to be my perfect opportunity. Yes, indeed. Stay tuned if you're watching on Nathan Oakley, but for the live audience, a huge, massive, enormous thank you for tuning in. Hopefully sharing, subscribing, smashing the super chat and all that good stuff. A huge thank you to Paula, Betty, Quantum Eraser, Anthony, and indeed Adam, the Adam Meakin, for making this Ballbusters possible. I've been Nathan Oakley, and I'll see you all in the next Ballbusters.